Da-da-da. Welcome to your CompTIA A Core 1 crash course. Whether you're diving into tech for the first time or giving your skills that final polish before the big exam, this is your go-to guide to mastering everything from motherboards to mobile devices. We're going to cover it all, but don't worry, we'll keep it fun, easy, and surprisingly painless. Think of it like the ultimate tech buffet. Grab what you need, skip what you already know, and leave full of confidence. So, grab a snack, settle in, and let's make sure you're ready to pass this exam with flying colors. Like this video if you're tired of tech jargon, and subscribe for clear, concise explanations. Here's what we've got lined up for today. We'll start with motherboards, breaking down form factors, chipsets, and troubleshooting tips. Then, we'll dive into CPUs and cooling, explaining cores, sockets, and how to keep your system cool under pressure. Next, we'll cover RAM and storage, comparing HDDs and SSDs and why RAM is so important. Power supplies are up next, where we'll show you why this often overlooked component is key to avoiding random shutdowns. After that, we'll tackle peripherals. From keyboards to printers, we'll give you quick fixes for common issues. In networking, we'll teach you how to eliminate Wi-Fi dead zones and set up routers and switches. Moving on to mobile devices, we'll cover troubleshooting for phones, tablets, and wearables. Then, we'll demystify virtualization with a simple explanation of cloud computing. Finally, we'll wrap up with troubleshooting, arming you with the skills to fix hardware, networking, and mobile device issues like a pro. By the end, you'll be ready to ace your exam with confidence. The motherboard is the heart of your computer. It's what connects all the components together. Different motherboards come in different form factors, such as ATX, Micro-ATX, and ITX. These determine the size of the board and what kind of components it can fit, like how many expansion slots or ports are available. You'll need to be familiar with the variety of chipsets on motherboards, which control how fast information flows between the CPU, RAM, and storage. Motherboards also have expansion slots like PCIe and PCI, where you can add extra hardware like graphics cards or sound cards. For the exam, you'll need to understand how BIOS UEFI helps the system boot up and how it manages communication between all components. Don't forget about the I/O connectors for USB, Ethernet, and HDMI, which help connect external devices to your computer. You'll also learn about power connectors that ensure electricity is supplied to the motherboard and components, and how the small CMOS battery keeps your system clock and BIOS settings in place. Finally, troubleshooting motherboard issues is key. If a computer isn't starting up properly, you'll need to know how to interpret beat codes and post errors to figure out what's wrong. The CPU, Central Processing Unit, is often called the brain of your computer. It handles all the instructions and calculations your system needs to run smoothly. CPUs come in different socket types like LGA and PGA, which refer to how the CPU fits in the motherboard. You'll need to know how different types of CPU cores like dual-core, quad-core, or even octa-core affect performance. More cores usually means better performance because the CPU can handle multiple tasks at once. You should also understand hyperthreading and multithreading, which helps make a CPU more efficient by allowing one core to handle multiple processes. A key part of managing CPU performance is understanding thermal throttling, which occurs when CPU slows down to prevent overheating. We'll also discuss overclocking, which pushes a CPU to run faster than its normal speed. But this comes with risks, especially overheating, so extra cooling is needed. Cooling a CPU is essential, and you should know how to install heat sinks, apply thermal paste correctly, and choose the right fans. The exam also covers CPU architectures like x86 and x64, which affect how much data the CPU can process at once. Finally, we'll look at troubleshooting CPU issues like overheating or slow performance. Cooling systems are vital to keeping your computer's components safe from overheating. There are two main types of cooling you'll need to know for the exam: air cooling and liquid cooling. Air cooling is more common and uses heat sinks and fans to draw heat away from the CPU and other components. Liquid cooling, on the other hand, is more efficient but more complex. It involves using liquid to absorb heat and cool it down with a radiator. You'll need to understand the difference between intake fans, which pull cool air into the system, and exhaust fans, which push hot air out. It's important to place these fans correctly to create an optimal airflow with your computer case. We'll also cover how to manage fan speeds using PWM, pulse width modulation, or voltage control, to help keep your system cool without being too noisy. Recognizing the signs of overheating, such as system crashes, slowdowns, or sudden shutdowns, is essential. Knowing how to use temperature monitoring tools to keep an eye on CPU and GPU heat levels is another key skill. If your system is overheating, troubleshooting the cooling system, such as checking for fan failure or blocked airflow, is important to prevent damage. RAM, Random Access Memory, is a critical component of your computer as it temporarily stores data that the CPU needs to access quickly. For the Core 1 exam, you'll need to understand the different types of RAM: DDR3, DDR4, and the latest, DDR5. Each generation is faster than the last, and it's important to know which is compatible with your motherboard. There are two main form factors of RAM: DIMM for desktop computers and SODIMM for laptops. You will also need to know about single-channel, dual-channel, and quad-channel configurations. Using dual or quad channels can significantly improve performance as it allows the computer to access multiple memory modules at once. Another key concept is the difference between ECC RAM, error-correcting code, and non-ECC RAM. ECC RAM is mainly used in servers because it can detect and correct data corruption, whereas non-ECC RAM is faster but doesn't offer error correction. Understanding RAM speeds, measured in megahertz, and CAS latency, which measures the delay between memory requests, is also important for performance. For the exam, you should note how to properly install RAM. This includes handling it carefully to avoid electrostatic discharge, ESD, and ensuring it's compatible with the motherboard and CPU. You'll also need to troubleshoot RAM issues, like system crashes or blue screens, which are often caused by faulty or incompatible RAM. Storage devices are where all your data is saved, and there are several types you need to understand for the exam. HDDs, hard disk drives, are traditional storage devices that use spinning disks to read and write data. While they're slower than newer technologies, they're also cheaper and offer large storage capacities. SSDs, solid-state drives, on the other hand, are much faster because they don't have moving parts. SSDs come in several types, such as SATA SSD and faster NVMe SSD, which fit into M.2 slots on the motherboard. SSHDs, solid-state hybrid drives, combine an SSD and HDD into one, giving you the speed of an SSD with the storage capacity of an HDD. Another important concept is RAID, Redundant Array of Independent Disks. RAID combines multiple drives to either increase performance or provide redundancy. You should know about RAID 0, which speeds up performance by splitting data across multiple drives, called striping, and RAID 1, which mirrors data on 2 drives for backup. We'll also cover external storage options, such as USB drives and NAS, Network Attached Storage, which are useful for backups. The exam will test your knowledge of file systems like NTFS, FAT32, and exFAT, as well as how to partition a drive to separate different areas for data storage. You'll also need to troubleshoot storage issues such as disk errors, bad sectors, and slow data access. The Power Supply Unit, PSU, is responsible for delivering the necessary power to all the components in your computer. Understanding how to choose the right PSU is critical. First, you need to calculate the wattage your system needs based on your components. For example, a powerful graphics card or multiple hard drives will require more wattage. PSUs come in different form factors, such as ATX and SFX. These refer to the physical size of the PSU and how it fits into your case. You'll also need to know about efficiency ratings like 80 plus bronze, silver, gold, and platinum. A higher efficiency rating means that the PSU wastes less energy, generates less heat, and runs more reliably. Power supplies have different types of connectors, such as the 24-pin ATX connector for the motherboard, the 4 8-pin CPU power connector, PCIe connectors for graphics cards, and SATA connectors for storage devices. Troubleshooting power issues is a key skill for the Core 1 exam. If your computer won't power on or shuts down randomly, it could be due to a faulty PSU. Using a multimeter to check the voltage rails, plus 12 volts, plus 5 volts, and plus 3.3 volts, can help you identify power problems. Additionally, protecting your system with surge protectors or a UPS, uninterruptible power supply, is essential to prevent damage from power surges or outages. Peripherals and input devices allow you to interact with your computer. Some of the most common peripherals include keyboards, mice, and trackpads for input, and monitors, printers, and speakers for output. You'll need to understand how these devices connect to the computer, typically through USB, Bluetooth, or Wi-Fi. You should be familiar with different USB standards: USB 2.0, USB 3.0, USB 3.1, USB 3.2, and USB Type-C. These standards determine the speed and type of connection. For example, USB 3.2 is much faster than USB 2.0, and USB Type-C is becoming the preferred connector for many modern devices due to its versatility and faster data transfer rates. Monitors connect via HDMI, DisplayPort, VGA, or DVI, each offering different levels of video quality and features. Printers and scanners also come in different forms, and understanding how to connect and troubleshoot them is essential. For the Core 1 exam, you will also need to know how to troubleshoot issues with peripherals, such as when devices aren't recognized by the system. Often, the solution involves installing or updating device drivers or checking connections. Displays are how you see what's happening on your computer, and there are several key features to understand for the exam. First, you'll need to know the difference between LCD, LED, and OLED monitors. LCD, liquid crystal display monitors, are common, affordable, and offer decent image quality. LED, light-emitting diode, monitors are similar but more energy efficient, while OLED, organic LED, monitors offer superior color contrast and quality, but at a higher price. Resolution is a key concept, as it determines how clear the images on your screen will be. Resolutions like 720p, 1080p, 4K, and even 8K refer to how many pixels make up the display. Higher resolution means a sharper image. You will also need to understand refresh rates, like 60 Hz, 120 Hz, and 144 Hz, which determine how many times per second the screen refreshes. A higher refresh rate is better for fast-moving content like games or videos. Aspect ratios like 16:9 widescreen or 21:9 ultra-wide describe the shape of the display. Color depth, measured in bits, such as 8-bit, 10-bit, or 12-bit, refers to how many colors the monitor can display, with more bits providing more accurate color. The Core 1 exam will also cover troubleshooting common display issues, such as dead pixels, flickering screens, or resolution mismatches. It's important to understand how to fix these issues by adjusting settings or updating drivers. You should also know how to troubleshoot connections using HDMI, DisplayPort, VGA, and DVI cables, and manage multi-monitor setups. Printers are essential for turning digital files into physical copies, and scanners allow you to digitize physical documents. You'll need to know about different types of printers, such as inkjet, laser, thermal, and dot matrix. Inkjet printers are great for printing high-quality images, while laser printers are faster and more cost-efficient for printing lots of text. Thermal printers are used for labels and receipts, while dot matrix printers are more commonly found in industrial settings. Printers connect to your computer via USB, Ethernet, or wirelessly through Wi-Fi. Printer consumables like ink, toner, and paper will need to be replaced regularly. For the exam, you'll also need to troubleshoot common printer problems, like paper jams, low ink, or poor print quality. Scanners are used to convert physical documents into digital files, and they come in flatbed, sheet-fed, and portable forms. Knowing how to troubleshoot both printer and scanner issues, such as driver problems or connection issues, will be key to passing the Core 1 exam. Hardware issues can be frustrating, but with the right approach, you can diagnose and fix them efficiently. Common hardware problems include no power, overheating, and random shutdowns. The exam will test your ability to troubleshoot these problems using diagnostic tools such as multimeters for checking the power supply and MEMTest86 for testing RAM. If your system isn't booting up, POST, Power On Self-Test, codes and beep codes can help you identify where the problem lies. POST codes are displayed on screen or through LED indicators on the motherboard, while beep codes are audible signals. Hard drive failures can result in slow performance, data corruption, or even complete data loss. Learning how to troubleshoot and recover from hard drive failures is essential. Similarly, issues with the motherboard, GPU, or other components can be diagnosed by understanding how the devices interact with the system. The Core 1 exam will also test your knowledge of hardware bottlenecks, such as CPU, RAM, or storage devices slowing down overall system performance. Identifying these bottlenecks and replacing or upgrading components can significantly improve system performance. Networking is an important part of the Core 1 exam, and it starts with understanding the OSI model, which breaks down network communication into 7 layers. These layers help you understand how data moves from one device to another. You'll also need to know the differences between IPv4 and IPv6 addressing. IPv4 uses 32-bit addresses, which limits the number of available IP addresses, while IPv6 uses 128-bit addresses, offering much more capacity. Subnetting, which involves dividing a large network into smaller networks, is an important topic as well, and you'll need to understand how to use subnet masks and CIDR notation. The TCP/IP model is crucial too. TCP, Transmission Control Protocol, is reliable but slower, but it ensures data is received correctly, while UDP, User Datagram Protocol, is faster but doesn't guarantee data delivery. Be sure to study how default gateways, DNS, and DHCP work together to keep network devices communicating properly. Finally, you'll learn how to troubleshoot common network issues like IP conflicts, slow network speeds, or no internet connection. Being able to diagnose network issues is a key skill for the Core 1 exam. A functioning network relies on many different devices working together. Routers direct traffic between your home or office network and the internet. They're essential for connecting multiple devices to a single network. Switches, which connect devices within the same network, are also important, and knowing the difference between managed and unmanaged switches will help you in the exam. Modems connect your home network to the internet via your internet service provider, ISP. And access points extend wireless coverage, allowing more devices to connect to the network. You'll also need to understand the role of firewalls, which protect your network by controlling the flow of traffic in and out. Knowing about NICs, network interface cards, which allow computers to connect to a network, and PoE, power over Ethernet, which lets certain devices like security cameras receive power through the network cables, is crucial. Be prepared to troubleshoot common network device issues, such as when a router isn't distributing internet properly or an access point is failing to extend coverage. Wi-Fi standards have evolved over the years, and for the exam, you'll need to understand the differences between 802.11a, b, g, n, ac, and the newest Wi-Fi 6, 802.11ax. Each of these standards offers different speeds and ranges, with Wi-Fi 6 providing the fastest speeds and the ability to support more devices simultaneously, which is especially important for busy networks. Wi-Fi operates on two frequency bands, 2.4 GHz and 5 GHz. The 2.4 GHz band has a longer range but slower speeds, while the 5 GHz band offers faster speeds but with a shorter range. Knowing how to choose the right Wi-Fi channel to avoid interference from other devices, such as microwaves or cordless phones, is key to improving performance. You should also understand the different Wi-Fi security protocols like WPA, WPA2, and WPA3, which helps protect wireless networks from unauthorized access. Technologies like MIMO and MU-MIMO improve the performance of Wi-Fi networks by allowing multiple devices to communicate with the router at once. Be sure to troubleshoot Wi-Fi issues like signal drops, interference, and connection problems to fully prepare for the exam. Networking also relies on physical cables and connectors. You'll need to know about the different types of Ethernet cables, such as Cat5e, Cat6, and Cat7. The higher the category, the faster and more reliable the connection. Cat6a and Cat7 cables, for example, offer much faster speeds and longer distances than Cat5e. Fiber optic cables are used for high-speed internet connections over long distances. These cables are available in two types: single mode for longer distances and multi-mode for shorter connections. Coaxial cables, which are commonly used for TV and broadband, are another key topic. For the exam, you'll also need to understand RJ45 connectors, which are the standard plug for Ethernet cables. Learning how to crimp cables and use cable testers to ensure a strong connection is vital for troubleshooting network issues. Good cable management is also important for keeping networks organized and running efficiently. Network topologies describe the way devices are connected in a network. The most common is the star topology, where all devices are connected to a central hub, such as a router. This setup is widely used in home and office networks. In a mesh topology, devices are connected to each other directly, creating a web of connections. This setup is more reliable because if one connection fails, data can still travel through another path. Bus topology uses a single communication line for all devices to share, while ring topology forms a closed loop where data passes from one device to the next. You'll also need to know about hybrid topologies, which can combine different types of network layouts. LANs, local area networks, WANs, wide area networks, and MANs, metropolitan area networks, describe networks on different scales. VPNs, virtual private networks, are important for securing remote access to a network, especially for remote workers. When troubleshooting networks, having the right tools can make all the difference. Ping is a basic command that tests whether a device can be reached over the network. and traceroute helps track the path the data takes to reach its destination. These tools can help pinpoint where a network problem is occurring. You'll also need to know how to use ipconfig for Windows and ifconfig for Linux to configure network settings and check the current status of your device's connection. NSLookup is another important tool that allows you to look up DNS records, which can help resolve domain name issues. For physical network issues, cable testers can be used to check if an Ethernet cable is working properly, while Wi-Fi analyzers help identify signal strength and possible interference. Network monitors allow you to analyze traffic and bandwidth usage, which is useful when diagnosing performance problems. Wireless networks are convenient, but they can also be prone to problems. One common issue is signal interference from household devices like microwaves or cordless phones. Adjusting the Wi-Fi channel can help reduce interference, while router placement is critical for optimizing signal strength and coverage. Sometimes a Wi-Fi network doesn't show up, or devices can't connect. This could be due to incorrect SSID, service set identifier, or network name, settings, or hidden networks. If there are areas in your home or office with poor signal, using Wi-Fi extenders can help boost the signal. Ensuring that your router's firmware is up to date is important for keeping your wireless network stable and secure. Rebooting or resetting the router or modem often resolves connection issues. MAC address filtering, which controls which devices can access the network, adds an extra layer of security. Diagnosing dropped connections often involves checking signal strength, router settings, and potential interference. Securing a network is critical to prevent unauthorized access and protect data. Firewalls act as a barrier between your network and the outside world, controlling what traffic can enter or leave. NAT, network address translation, is another important security measure that hides your internal IP addresses from external networks. A DMZ, demilitarized zone, isolates certain devices or services from the rest of the network, providing an extra layer of security. VPNs, virtual private networks, are essential for creating secure, encrypted connections when accessing a network remotely. MAC address filtering allows you to control which devices can connect to the network by using the unique MAC address of each device. Port security limits the number of devices that can connect to a specific switch port. And VLANs, virtual local area networks, are used to segment a network for better security and performance. Understanding how to implement encryption protocols like SSL and TLS ensures that data is securely transmitted over the network. You'll also learn about network security policies that control access and enforce the principle of least privilege, where users only have access to the resources they need. Small office, home office, SOHO, networks are becoming more common as people work remotely or run small businesses. Setting up a SOHO network usually involves connecting a router, switch, access points, and printers. You'll need to know how to configure the SSID and set secure network passwords to protect the wireless network. In a SOHO environment, file and printer sharing across the network is essential for collaboration. As more IoT, Internet of Things, devices become common, such as smart thermostats or security cameras, understanding how to integrate these into your network will be important. You may also need to set up a guest network for visitors, which keeps them separate from the main network for security reasons. Troubleshooting SOHO networks often involves solving performance issues like slow speeds, interference, or bandwidth overload. Setting up port forwarding allows users to access internal devices from outside the network, such as accessing a security camera or media server remotely. Virtualization allows multiple operating systems to run on a single physical machine, and it's a key concept in the Core 1 exam. Virtual machines, VMs, let you create and manage these environments. You'll need to understand how hypervisors work. Type 1 hypervisors run directly on hardware, while Type 2 hypervisors run on top of an existing operating system. When setting up VMs, you'll allocate resources like CPU, RAM, and storage to ensure they run efficiently. Cloud computing services are also covered with IaaS, Infrastructure as a Service, PaaS, Platform as a Service, and SaaS, Software as a Service, being the main types of cloud models. These allow businesses and users to access resources over the internet without needing physical hardware. Cloud storage solutions like Google Drive, OneDrive, and Dropbox are also important to understand. You'll need to know the differences between public, private, and hybrid clouds, which offer varying levels of control and security. Virtual networking, which connects virtual machines to the physical network, is another key concept. You'll learn about bridged versus NAT, network address translation, modes, and how to troubleshoot issues related to performance, storage, and networking in virtual environments. Mobile devices such as smartphones, tablets, smartwatches, and IoT devices are essential parts of everyday life. And the Core 1 exam covers how these devices work. You'll need to know about the most popular mobile operating systems, such as iOS, Android, and Windows. These systems are responsible for managing the hardware and software on mobile devices. The internal components of mobile devices, like the battery, display, processor, and storage, function similarly to desktop computers but are designed to be more compact and energy efficient. Mobile devices also have different input methods, such as touchscreens, styluses, and even voice control. For the exam, you'll need to know how to troubleshoot common mobile device issues, such as freezing, crashing, or unresponsiveness. You'll also learn how to diagnose charging problems, which may be related to a faulty charger, battery, or a charging port. Mobile devices rely on several types of connectivity to function properly. Cellular networks such as 3G, 4G, LTE, and 5G provide mobile data access, with each generation offering faster speeds and better reliability. Wi-Fi is another key method of connectivity for mobile devices, and it's important to know how to set up and secure Wi-Fi connections on mobile devices. Bluetooth is used to pair devices, such as wireless headphones or keyboards, and transfer data over short distances. NFC, near-field communication, is a technology that allows devices to communicate by simply touching or being in close proximity. And it's often used for mobile payments or sharing data. Mobile devices can also act as a hotspot, sharing their internet connection with other devices. Airplane mode disables all wireless communication on a mobile device, which can be useful for saving battery life or when traveling. You'll also learn how to troubleshoot mobile connectivity issues, such as Wi-Fi drops, Bluetooth pairing problems, or cellular signal loss. Security is a crucial aspect of managing mobile devices, and the Core 1 exam will cover how to protect mobile data. Passcodes and PINs are the most basic forms of security, but modern devices now offer biometric security features, such as fingerprint scanning and facial recognition. To protect the data stored on mobile devices, device encryption is often used. Encryption ensures that if a device is lost or stolen, the data remains secure. Features like Remote Wipe, available through tools like Find My iPhone or Google Find My Device, allow users to erase their data remotely if their device is lost. You'll also learn about managing app permissions, which control what data and functions each app can access. Security updates are essential for keeping the device safe from the latest threats. Anti-malware tools are available for scanning and removing malicious apps. Finally, understanding how to back up mobile data, either to the cloud or locally, is crucial for protecting important information. If a device is compromised or experiencing serious issues, performing a factory reset may be necessary to restore it to its original state. Managing mobile devices involves more than just basic use. You'll need to know how to adjust settings for things like brightness, notifications, Wi-Fi, and Bluetooth connections. Battery management is also crucial. Understanding how to optimize battery life and use power-saving modes can extend the life of the device. Managing storage is another key task. You can free up space on mobile devices by clearing the cache, deleting unused apps, or transferring files to an external storage or the cloud. Backup and restore options are essential for protecting data and ensuring that important information is not lost. Keeping mobile devices up to date with the latest system updates is important for both performance and security. If the device is running slowly or experiencing frequent crashes, you may need to troubleshoot the issue by force restarting the device or performing a factory reset. Mobile devices can be enhanced with various accessories. Common accessories include chargers, docks, cases, and screen protectors. Wearable devices, such as smartwatches and fitness trackers, are becoming increasingly popular and can connect directly to smartphones for added functionality. For additional storage, some mobile devices support USB OTG on the go, which allows you to connect external drives. Cloud storage is another option for backing up files or extending storage capacity. Bluetooth headphones are another common accessory, and you'll need to know how to troubleshoot pairing or connectivity issues. Many modern devices support wireless charging following the key standard, which eliminates the need for charging cables. VR headsets are also available for use with mobile devices, providing immersive virtual reality experiences. Power banks are another essential accessory for keeping mobile devices charged when you're on the go. When troubleshooting a problem, a methodical approach is essential. The first step is to identify the issue by gathering information and observing the symptoms. Once you've identified the problem, test possible solutions, one by one until you find the fix. After the issue has been resolved, it's important to verify that the problem has been properly fixed and won't return. Keeping a log of issues and solutions can be useful for future reference, especially when dealing with recurring problems. Understanding common error messages and how to interpret them will help you quickly pinpoint the cause of the issue. Diagnostic tools such as multimeters for checking power or memory testers like MEMTest86 are crucial for diagnosing hardware problems. You'll also need to learn how to prioritize issues based on their severity. For example, power issues should be resolved first, as they can prevent the entire system from functioning. Less critical issues, like minor software bugs, can be addressed later. Rebooting or resetting a device is often a simple fix for many problems. Keeping drivers and firmware updated can also prevent future issues. Hardware issues can cause a wide range of problems, from a system that won't power on to components that overheat or fail. Power-related issues, such as no power or random shutdowns, are often caused by problems with the PSU or power connectors. Overheating can lead to system crashes or slow performance, so it's important to check that fans and cooling systems are working properly. If the computer fails to boot, BIOS, UEFI settings, or post errors might be the cause. Adjusting the boot order or checking for faulty hardware may resolve the issue. Memory errors like blue screens or system crashes can be caused by faulty RAM. Running a memory test will help you diagnose the problem, and you may need to reseat or replace the RAM. Hard drive failures are another common issue, leading to data corruption or slow performance. You'll need to know how to diagnose and recover data from failing hard drives. Motherboard issues, such as post errors or GPU failures like artifacts on the screen or no video signal, are also common hardware problems. Understanding how to identify and troubleshoot these issues will be essential for passing the exam. Network issues can range from minor annoyances to complete outages. If you have no internet connection, the issue could be physical, a disconnected cable, or related to network settings, incorrect IP configuration. Learning how to use basic networking tools like ping and traceroute can help identify where the problem is occurring. An IP conflict happens when two devices on the same network are assigned the same IP address. This can cause connectivity issues, and it can be resolved by renewing the IP address or adjusting the network settings. Slow network speeds can result from many causes, such as bandwidth congestion, outdated hardware, or signal interference. Wireless drops may be caused by interference or poor signal strength, and router settings may need to be adjusted. Limited connectivity could point to DNS or gateway issues, and fixing firewall rules or adjusting router settings might be necessary. Tools like Ping and Traceroute can help you troubleshoot where the issue is happening. Mobile devices can experience a wide range of issues, from battery drain to slow performance. One of the most common complaints is that the battery drains too quickly. This can often be caused by apps running in the background or settings like Bluetooth or Wi-Fi being left on unnecessarily. Managing these settings can help improve battery life. Slow performance can often be fixed by clearing the cache or closing apps running in the background. App crashes or freezing can usually be solved by updating or reinstalling the problematic app. Connectivity issues such as Wi-Fi, Bluetooth, or cellular signal problems are common on mobile devices. These issues are often resolved by resetting the connection or rebooting the device. If the device's screen becomes unresponsive, a forced restart may be necessary. Overheating can occur when a device is being pushed too hard, such as running multiple apps at once or being used in a hot environment. Properly managing storage by transferring files or deleting unused apps can also prevent performance issues. Printers are known for causing issues, but many problems have simple fixes. Paper jams are one of the most common problems, and they can usually be cleared by following the printer's instructions. Using the correct weight of paper for your printer can also help prevent jams. If your print quality is poor, such as streaks or faded prints, it may be time to clean the print heads or replace the ink or toner. If the printer is not responding, check the power connections and drivers to ensure that everything is set up correctly. For network printing issues, ensure that the printer is correctly connected to the network and that it is visible to other devices. Printer calibration ensures that prints come out accurately, and troubleshooting wireless printer setup is often necessary to ensure proper connection. Display issues can be frustrating, but many of them have simple solutions. If your monitor shows no signal, the first thing to check is whether the cables are connected correctly and the monitor is powered on. Dead pixels are small, non-functioning spots on the screen, and they can sometimes be fixed by applying gentle pressure or using pixel-fixing software. A flickering screen can be caused by refresh rate issues or driver problems. Adjusting the refresh rate or updating drivers usually resolves the issue. If the screen's resolution doesn't match the monitor's native resolution, you can correct this in the display settings. Display artifacts, such as visual glitches, are often related to GPU issues, so updating or reinstalling the graphics driver can help. Brightness or color distortion may be caused by incorrect calibration, and adjusting the display settings will help fix the issue. For multi-monitor setups, troubleshooting involves ensuring that the settings are configured correctly to extend or duplicate the display. Software issues can cause a wide range of problems, from slow boot times to crashes. Slow booting is often caused by too many programs running at startup. Disabling unnecessary startup programs can speed up the process. Application errors can often be fixed by updating or reinstalling the software. If your system is infected with malware, running its scan and removing the infection will restore normal functionality. The blue screen of death, BSOD, often points to a hardware or driver conflict, and understanding how to interpret error codes is key to resolving the problem. Program compatibility issues may arise when running older software on a newer operating system. Running the software in compatibility mode can usually solve this problem. If you encounter software licensing issues, such as an activation failure. Reinstalling or reactivating the software may be necessary. In some cases, you may need to reinstall the operating system to fix persistent software problems. Now that we've covered the key hardware topics, let's review what you've learned. Motherboards house all your components, and we've explored how CPU socket types, chipsets, and expansion slots affect system performance. You should now be comfortable identifying different types of RAM and how channel configurations impact memory performance. We also looked at storage devices, including HDDs, SSDs, and RAID configurations, and learned how to troubleshoot storage failures. Understanding power supplies and calculating the necessary wattage for your components is crucial for building a stable system. Finally, we reviewed common display and printer issues and discussed how to troubleshoot hardware issues, such as no power, overheating, or random shutdowns. These key hardware concepts will be critical for your exam. Next, let's review the key networking concepts. We explored the OSI model, which breaks down how data moves through a network. You should also be able to explain the differences between IPv4 and IPv6, and how subnetting divides a larger network into smaller subnetworks. Understanding wireless standards like 802.11a, b, g, n, ac, and the latest Wi-Fi 6, 802.11ax, is essential for configuring and troubleshooting wireless networks. You should also know the roles of network devices, such as routers, switches, and modems, and how to identify and fix networking issues like IP conflicts or slow network speeds. Being familiar with different types of Ethernet cables, such as Cat5e, Cat6, and Cat7, is important for ensuring reliable connections. You should also review network topologies like star and mesh, and the different tools available for troubleshooting network problems, such as ping, traceroute, and cable testers. Let's wrap up by reviewing mobile devices and virtualization. We covered the main components inside mobile devices, such as batteries, processors, and displays, and how to troubleshoot common mobile issues like battery drain or slow performance. You should also be familiar with mobile connectivity methods, including Wi-Fi, Bluetooth, NFC, and cellular networks, and how to manage mobile security with pins, biometrics, and encryption. We also discussed virtualization, which allows multiple operating systems to run on a single piece of hardware. You should know the difference between Type 1 and Type 2 hypervisors, and how to allocate resources like CPU, RAM, and storage for virtual machines. Cloud computing models like IaaS, PaaS, and SaaS are important concepts to review for the exam. Now that we've gone over all the key topics, it's time to focus on exam preparation. Hands-on practice is the best way to get ready, so make sure you've spent time configuring networks, installing hardware, and troubleshooting systems. Practice exams and labs will help you identify any weak areas, so focus your study on those. Keep up with the latest technologies, like Wi-Fi 6 and NVMe SSDs, as they may appear on your exam. Review your study guides, notes, and practice tests, and focus on areas where you feel less confident. Remember, confidence is key. You've worked hard to prepare, and now it's time to show what you know. On the day of the exam, make sure to arrive early at the test center, or prepare your space if taking a remote exam. Check that you have everything you need, including your ID, calculator, and any allowed materials. When answering questions, take your time and read carefully. If you've come across a difficult question, don't panic. Flag it and come back to it later. Pacing yourself is important, so don't rush through the exam. Stay calm and take deep breaths if you start feeling stressed. Trust in your preparation, and remember that you've got this. Focus on one question at a time, and you'll be ready to pass your CompTIA A Core 1 exam with confidence.